Hey everyone, Paul Mann here, and welcome to my videos on Practical Python. In this video, I'll show you how to import data from various file formats using Pandas to verify, filter, and merge that data in your Python code. Pandas introduced two new data structures to Python for this purpose. A series, which is a one-dimensional array similar to a column in a spreadsheet, and a dataframe, which is a two-dimensional array made up of multiple series and looks very like a typical spreadsheet with rows and columns. We'll be working mostly with dataframes in this video. The thing that makes these structures so powerful in your code is the index object, which can be used to identify, filter, and select entries with your code. I'll be working in PyCharm as usual, but we'll be using the Python console instead of the editor. The code in the Python console is interactive, meaning that you get immediate feedback as you type your commands. The console is a great place to work with dataframes because you can verify and view the data in real time. A Jupyter Notebook is another popular idea among data scientists for doing this, but for the sake of consistency, we'll use PyCharm. Console has everything we need for our data analysis and more. So we're going to import a CSV file, an Excel file, and an API or via a JSON file. And then we'll learn how to take these files in and verify, summarize, filter, and select subsets from the data. So I do have some files over here on the left that we're going to use in our examples. We'll start off with the Titanic CSV file and use that. So to import these files into Pandas is really easy. There's no need for the file open command or any additional code. It's just one line. I'm going to use the Python console down here. You can also find it in the menu. So the first thing we need to do in the console is import the Pandas. Import Pandas as PD. And then we'll create our data frame. We'll create a variable df and we'll read in the CSV file, the Titanic CSV. And that's all it takes in Pandas to import a file into your code. So it's really easy, no need to use the open file command. So also, if you remember in the last video, the comma delimited file that we downloaded was not actually comma delimited, it was semicolon delimited. So we need to update that if we want to get an accurate data frame. If you click the little glasses over here on the left now at this point, when you have your data frame, you can go in and see all the fields and all the attributes and fields in the data frame. You can also click this view as data frame, which is a really handy tool, and it shows you a graphical perspective of the data, and you can go through that and make sure it is what you expected it to be. But when you print out the data frame initially, you'll see that it's compact. The little dots, the three dots, mean that there's more data in between here, but what Pandas is doing is compacting it so that it looks well on the screen. That's fine for the columns, but for the rows we want to see all the rows, so we're going to change that setting with this command, with this option here. And you can do this for the columns as well. I don't recommend it, but you would just replace rows with columns. It's better not to do it with the columns because what Pandas does is it doubles up and it's hard to see what data you have on the screen. But this is good for rows, and now we should print all the rows in the data frame. So now when we print, we see all 891 rows. So now that we've imported our data frame and it seems to be populated reasonably well, we want to verify the data. So the first way we can do that is use the head method, which will give us the first 5 lines of the data frame, and we can see the columns in that. And then we can also use the tail method to get the last 5 lines in the data set. The shape method will give us a numeric feedback on the amount of rows and columns in the data frame. So we have 891 rows with 12 columns. This is really handy with large data sets as well. The info method gives you a list of column headers. It also gives the non-null values and the data types. The data types in our case is integers, objects, which is text, and then we have floating point, which is decimal point. So the non-null value is interesting. It shows which columns have null values. So for example, on 5 for age, you have only 714 out of 891 with values in this. I assume this is something to do with being improper in high society to disclose your age. Maybe, that's my guess. But regardless, in our data set here, there are quite a few cells in the age column that have null values. The data type attribute, and it's an attribute, it doesn't have the parentheses at the end, gives similar information and info. It doesn't give the non-null values, but it gives the type data types and the column headers. That should be enough commands to verify and inspect the data. Now, if you want to describe it, if you want to get a summary of what kind of data you have, one great method to do that is the describe method. And what that does is gives a list of statistics on the integer value. You can change it to apply to text values too, but out of the box, it does the integer values and gives you some key data points. So in our example, we can see that the minimum age on the boat was 0.42 years old and the oldest was 80 years old. The most expensive ticket on their fare was $512 or pounds, and the minimum was free. So these can provide some insight into your data. You can also do these separately or individually if you choose, but this is like a quick overview. So for example, if you wanted to sum up all the fares that were paid on that voyage, you could go to the fare column, DF fare, and sum that column up and you would get $26,693 or pounds, and that would be what was paid in total for that original trip. So the point is here that there are lots of methods that are already there that you can manage in some columns and get the mean and do a lot of things in dataFrames without writing any code or very little code. So one of the attributes that I forgot to mention was columns, and this is important because it gives you a quick list of all the columns in your data, and you can often use this to iterate through the columns or to delete columns, for example. So this is something you'll use a lot. So now that you've finished verifying and inspecting and summarizing your data, you'll want to incorporate that into your code. So you'll bring in your data and you'll process it however you plan to process it. So you want to copy the commands that you've run here to get the variables that you want. And one way to copy it is to click this little clock here on the left of the Python console, and that'll show you the list of commands that you've typed, and you can go in and copy these commands and paste them into your editor for your code. I assume that that's the purpose of going in and verifying these data sets, is that you want to write some script or you want to write an application that automates this process. So now it's time to actually go and find some values in our data. And one way of doing that is getting a list of a certain column. In our case, we'll look at the name column and we use the dot notation, and we'll get a list of names in our data with the index on the left. Keep in mind the index will be one less than the rows on the list because it begins at 0. So another way of doing this will be with brackets, and you should consider the column in a data frame as a key in a dictionary, Python dictionary, and the values in that column are the values in the dictionary. So when we type the bracket notation, we're actually pulling up the key of a dictionary with the values as the list in it. So if we want two columns, we'll have to send a list to that notation. So that's why we'll have the double brackets. And this will show two columns of name and age. The NaN is not a number, it's just another term for null value. But these are just two common ways of getting lists from a data frame. One way we can get a subset of rows is by using the all-powerful index in the data frame. So here we're going to get the first 20 rows. Another thing here, we get 50 to 100 rows. We can slice this up anyway. And again, think of it as a dictionary, which it pretty much is. And instead of the column being the name of the dictionary or the key, then it's the index. So now let's try and get two names, the name and the fare, along with the index. So we'll get these two columns for the first 20 rows. While this works for getting specific rows with specific columns, it's really not that efficient. And the recommended way for Pandas and data frames is to use two attributes called the low and the iloc. Low is short for location and iloc is integer location, and these two attributes are used to get specific rows for certain types of data. So they're attributes, not methods. They don't have the parentheses at the end, but they do have square brackets, which means that they're indexable attributes, where the attribute you put in the variables or you put in the specifics in the brackets, and that's what the low or iloc attribute will pull from your data frame. So let's see in an example how this works. So here we'll just put the index in the brackets, the first 20 rows, just like we did before, and as you can see, it pulls it right up, and this is a more efficient way of doing it. We can also put the names in. We'll put that in a separate bracket. So notice that instead of sending two lists like we did before, Now we have the low attribute, so we use a one attribute with two indexes that we need. So it's the name and the fare, and then it's the first 20 rows. So the rows are always first in ILO and low, and the columns then are second. So if we get a list of columns, we can use the ILO function, which is numbers only, to think of it as an integer location. So it's the rows first again, so we'll get the first 20 rows. And next we put the columns by numbers, again starting at 0. So passenger ID is 0, so if we want the name, that would be the third column. And if we want the fare, that would be the 9th column. So it would be 3, 9 would be the two columns we need. And here we get a list of names and fares paid. So now we want to get a subset of rows based on a certain criteria. We could do the dot notation with the column and put in a greater than 60 years of age, for example. But we get a Boolean list here, and this is not very helpful. We could write some code to parse out the true, but that's clumsy. A better way of doing it is to go back to the low location again and just put in the index the criteria that we're looking for. So in this case, the criteria is age greater than 60 years old. And this is a much better way of doing it. We get a list from our data frame of passengers that were over 60. If we wanted to get just certain columns with our result, then we'd put in a list of indices. So we'd have greater than 60, and then put in another list of name and age, for example. So this will just give us two columns with the people that are over 60 and the age, so we can verify that our criteria is correct. So finally, let me show you how to add multiple criteria to get two pieces of data. So we'll use the low again, and we'll put in people in first class that did not survive. So be P class is the column for class, and then put in 1 for first class. We have to put these in parentheses. So, and you also, the ampersand has to be used for the and statement. A straight line, a vertical straight line is used for or. And then in the next one, we'll put the people survived equal to no. So basically the people on the Titanic that were in first class that did not survive. And you can see there were 80 rows, so 80 people in first class perished. So let's just see how well third class fared out. So we just change the class to 3. So we can deduce from this analysis that when your ship hits an iceberg, you have a much better chance if you're holding a first class ticket. So that's it on how to retrieve data. Just one note on deleting data. If you want to delete columns, which can often happen if your data set if there are too many columns. So that's easy. It's just type delete and bring up the column name. We'll use cabin in our example here. We hit enter, and that's it. If we do df columns, we'll see that the cabin column is no longer there. So there shouldn't be too much deleting data when you're bringing data into Python. My assumption is that you would retrieve whatever data from the data set you need and bring that into your code, and any deleting then would be done within the code. I may be wrong, but these are the main commands in dataFrames for Pandas. There are many, many more, and you can go to the link shown here if you want to learn about all of them, but the ones that I've gone through here are the most commonly used commands, methods, attributes, and functions for managing data in Panda dataFrames. So now let's work with a couple of spreadsheets. I have two example spreadsheets over here, one original and one new. They're almost identical. There's one line in the new that's not in the original, and I want to use these to show how to merge two data sets. For my own use case, I want to export data from a website or from a SQL database or wherever, and it comes into Excel, and then I want to check it every week or every day to see what's different. So this is a common task, and often I need to copy the result out to a different spreadsheet or update the existing spreadsheet. So we'll do that here very easily with dataFrames. So I've created one data frame here with the original sample, and I'll create a new one, df1, with the new sample file, the one that has an additional line. And we can see the data frames are created, and we first one df, we have 42 lines, 42 rows, and df1 has 43. So the columns and rows are all the same, but there's just one additional record on the df1. So we need to find that out. And with thousands of records, this can be very difficult to do. So we'll do a test here just to verify that we're looking at the same data sets from a schema perspective, in the sense that they have the same columns. The rows are going to be different. So if the shape will tell us that the df has 43 with 7 columns and df1 has 44 with 7 columns. We can confirm our suspicions that they are different with the equals. This is something you would write into your code to flag if there's a difference before you would proceed to concatenate or do whatever you need to do. In our case, it's false, so they're different. So now we'll create a variable called combined and put those two data frames into it with the concat method. We'll put the brackets in here to send a list. The list is df and df1. We'll drop the duplicate so we don't get two lists. And you can select what you want to duplicate on, what a column, but in our case it doesn't matter. And there's the combined list with 43 of the rows and then the additional row number 15. So now we have 44 rows, still 7 columns, and we've effectively merged those two spreadsheets together into one. Now if we want to save this out to an Excel file, we'd simply type combine to Excel and the name of the file. But before we can do that, we have to install a library called OpenPyXL. So OpenPyXL is really a phenomenal library, and you can use it on its own without Pandas, but it's really much easier with dataFrames. So we'll install the library. It's already installed here, but it's an easy install. And then we'll go back and we'll import it into our program. And now we're ready to save that file out to a spreadsheet. I recommend importing OpenPyXL into your code when you're working with dataFrames, because you will be working with spreadsheets. So we'll save it out to a file called myCombinedFile.xlsx. And when we look in our directory, we should see that file show up shortly. And there it is. And when we open it, we have the file, the Excel file, and the final line, the line 45, which is actually 44 minus the header. And there we have our file. That's a task that's common in processing spreadsheets and data from other data sources, and it's super easy with Panda DataFrames and OpenPyXL. The last thing I want to show you here is how to import an API or a JSON file from an API into a data frame. We'll go back to the regular PyCharm editor to do this. We don't need the console. We do need an additional library though. We need the request library, which is another phenomenal library that's used for APIs or to grab website data. I have a video that I recently did on this, on APIs, and this particular example that we have here is in it, so that will give you some background on APIs themselves if you need that. But essentially we're going to run this API, which is to get the weather in Miami, a couple of parameters that needs to go with it. This is the URL we're going to send out for. And we're going to send it the API key, my key. You'll have to put your key in there in lieu of that. And then the data frame is going to take the JSON response from that API request and pull it out. So we'll print the data frame here and we'll see it's in series, meaning there's 2 columns. We don't need the Python console to run it in. So we'll run it right in the terminal. And there we have the 2 rows. On the left, you have the columns essentially from the API with the specific values relating to the temperature and weather in Miami. So if we want to drill down further into this, we could use it like a dictionary and put the square brackets on the data frame and get those values on the left. So the main value, the main column seems to be where the temperature is, if that's what we're looking for. And then underneath that, then there's a value, or a key, called temp. So if we go main temp, we'll get the temperature in Miami currently. And there it is. So if we wanted that for our application, we'd have it 77.8, which is phenomenal weather for Miami. Lucky Miami. So using data frames in this context is really just a way to process the data that comes back from the API. We still have to run the API, but as you saw from my video on APIs, it can be a little tricky to plow down and get the actual values and the keys and the values. This is a little easier, and maybe it can be merged with other data frames in your application. So it's a handy tool to know how to use when you're using APIs. And there's a high level of using dataFrames and Pandas in Python to import CSV, Excel, and APIs. It's really powerful. It makes a lot of difficult functions very easy. Python's very good at data analysis and data science. And if you're going to get serious about that, you may want to explore Anaconda, which is a distribution for data science, and Jupyter, and all of those fantastic tools that are available to analyze data. This should give you an overview of how to get data easily into your program and manipulate it without too much hassle. So all the code that I have here will be on my GitHub site, which is at the link below, and you can get the sample files and the code that we used here. If you've enjoyed this video, please don't forget to share, like, and subscribe. So in the next video, we're going to look at plotting the data so we can look at it and see trends and analyze it better. Until then, stay safe. See you soon.